Hi, now we're going to graph a trigonometric function of the form sine x cosine x. Suppose first of all I want to graph cosine x. I'm going to take graphing by taking particular points. We know that cosine, we're going to take 0, pi over 4, pi over 2, you know the trigonometric circle. I'm taking 0, 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4 and 2 pi, the cosine. So for the first one, cosine is 0 is 1. Here radical 2 over 2. Pi over 2 here, cosine 90 is 0. 3 pi over 4 here negative minus radical 2 over 2. Cosine pi is minus 1, the x-axis. 5 pi over 4 it's also negative. 3 pi over 2 is also 0 here. 7 pi over 4, this is radical 2 over 2 and 2 pi is 1. You may take multiple of 30 and 60, no need to take all these points, it's enough. So if you want to start cosine 0, it is 1, pi over 4 pi. For example, 3.14 over 4, it's around 0.75 or so it is radical 2 over 2 which is 0.8, pi over 2 around 1.5. Take pi for example when you want to graph not to take 0.14, take it as a 3, around 3. So 3 over 2, 1.5 is 0, this is 1.50. Here if you take 9 over 4, if you take pi around 3 in graphing, so 9 over 4 around 2.25, so it is minus radical 2 over 2 minus 0.8. Pi 3 around the 3 in 3.14, 3 it's minus 1. 5 pi over 4 here, so it is 15 over 4 around less than 4. So it is minus radical 2 over 2 and 3 pi over 4 around more than a little than 4.5, it is 0, 7 pi over 4 here, and 2 pi 6.28, it is 1. So as you can see here, if you're graphing, this is the graph of cosine, right? So I have 4 quadrant as you can see, and since the circle can rotate it many times, so it will keep repeating from that side. You know, the thing that we graph here, the part that we graph here, from here till here, this is called one period, one revolution. You can repeat it here from the other side, the same, and it keep going from both sides. So this is the graph of cosine x. So mainly what I'm going to use from now and on, only 0, pi over 2, 5 pi over 4, 7, I'm not going to use this. I'm going to use 0, pi over 2, pi, 3 pi over 2 for graphing. Okay, so if you have it, let me tell you how. What I want to use from now and on, if I have 0, 1, suppose this is 0, 1. I have pi over 2, 0. Take pi when graphing as 3. 3 over 2 is 1.5 is 0. Suppose this is 1. 1.5 is 0. So here, this is the first point. Pi in 3 is minus 1. So here, 3 pi over 2, 4.5. 4.5 it is 0 here. And the last one, 6. It is 1. So if you want to graph it, it has that form. Please memorize the form of the cosine x that you have it here. Okay. Sine x, same story. We know sine 0, come in. Sine 0, the y-axis here is 0. Pi over 2, I'm going to use, as I said, pi over 2, it is 1, 0. Pi is 0. 3 pi over 2, you all know 3 pi over 2 here, 0 minus 1. Pi is 1 minus 1, 0, so 0. And 2 pi is 0. So if I use this one, 0, 0, pi over 2, this is the point. Pi 3.14 or 3 is 0, 3 pi over 2, 4.5, or it is -1, and 2 pi is also 0. So this is the form of graph y equals sine x, and it will keep repeating because rotation, you may have infinitely many rotation till minus infinity until plus infinity. So mainly this is the graph of cosine x, 0 pi over 2 pi, 3 pi over 2, 2 pi. So this is the curve as we said, 0, 1, pi over 2, 0, pi is -1, 3 pi over 2 is 0, and 2 pi is 1. So you graph, this is the form of cosine x. Sine x, it starts from 0, it's the same. This is the graph of, and we have one period which is 2 pi. All you need to memorize and to know these, okay? So let us start by before. If you have a curve of the form a cosine bx plus c plus d, I'm not going to graph only cosine x, sine x. The coefficient of cosine or sine, this is called in absolute value amplitude. Amplitude, it means in math, if you take for example the highest point, the y of the highest point and the y of the lowest point, and if you, let me repeat it. So here, the amplitude in math, it means amplitude is only in trigonometry. If you have a curve of that form, okay, so this is the maximum point, this is the minimum point. For this maximum point, you have y1, the elevation, and here you have y2. Amplitude, it means if you add in absolute value these two elevation, the maximum elevation and the lowest elevation, and you divide it by 2, you're going to get the amplitude. When graphing, you will understand it better. Period, always, if you have cosine x alone, the period you all know it's 2 pi, and the sine x is 2 pi. But however, if you don't have x, you have coefficient of x, for example 2x, the period is not anymore 2 pi, the period is 2 pi over coefficient of x. 2 pi over coefficient of x, and you have 4 quadrant, you divide this period by 4. What do you get? You divide it by 4. The phase shift is the initial revolution. When you start by sine x, we started by 0. But if you have bx plus c, we're going to start the initial rotation by equating this to 0, which is minus c over b if you equate it. This is called phase shift. And the vertical translation, we're going to talk about it when we're going to start the graphing. So these are the essential things we need to know. The amplitude coefficient of x, the period is 2 pi over b, coefficient of x, we divided by 4. We start by equating this to 0. This is called phase shift, and the vertical translation. You will understand by taking an example. I want to graph 2 cosine, parenthesis, pi x minus 2 pi minus 1. First of all, in absolute value, amplitude is absolute value of 2, which is 2. The period coefficient of x here is pi. So you take the 2 pi and you divide it by coefficient of x, which is pi. So the period here, pi and pi cancel out 2. So I have 4 quadrant. I divide this 2 by 4. So every length of the quadrant is 0.5. The phase shift, I equate this to 0. So pi x equal to pi. So x equal to pi over pi, which is 2. This is the phase shift. What does it mean? It means I'm going to start by number 2. You can see here the red part, number 2, the phase shift. 2. I add to it what? Each one quadrant. 2 plus 0.5. I add another 0.5, so 3. I add another 0.5, 3.5. I add another 0.5, it's 4. So as a total, the first one will be 2. The last one will be a phase shift plus the period. 2 plus 2, it ends at 4. And each time I add 0.5. Cosine x, this is the cosine x that I told you. 1, 0, minus 1, 0, 1. So what do you do now? As if this is all cosine x, you multiply each number by 2 and you add minus 1. So you multiply here by 2, and you add minus 1. 2 times 1 is 2 for any number you have, and then you put minus 1. 2 minus 1 is 1. For the second one, 2 times 0, here you put 0 now. 2 times 0 minus 1 is minus 1. Here, 2 times minus 1, because I have 2 times cosine minus 1. 2 times minus 1 is minus 2, minus 1 is minus 3. 2 times 0 minus 1 is minus 1. 2 times 2 minus 1 is 1. Now I go to the trigonometric, to the graph. 2 is 1. I put 2 is 1. I have 2.5. This is 2.5. It is minus 1. 2.5 minus 1. This is 2.5 minus 1. This is the first quadrant. Then 2.5. Then 3, you have minus 3. This is a 3 and this is minus 3. This is my point. Then you have a 3.5. You have minus 1 as you can see here. 3.5 minus 1. And then you have 4, 1. So I have the 5 points. So I graph it. So this is the function I have. And then it will keep repeating from here. This is one period. This is the initial period. This is the first period I have. Okay. So this is the initial one. So now you keep repeating. And from here till here, you have 2. So another 2 because the period is 2. So you keep repeating it, the same one, right and left. Now, what I want you to know, so as I said, this is the first period. Concerning the amplitude, if you take the highest elevation here and the lowest elevation here, the highest one is 1 and the lowest one, y, is minus 3. If you add it in absolute value and you divide it by 3, this is what's called amplitude. So it will be 4 over 2, 2. Okay, so the distance from here till here, if you divide it by 2, this is called the amplitude in math. It's 2. Mainly, we are not going to use this in graphing. However, we need to know it because we may get a question about amplitude in SAT2. So this is the amplitude, which is 2. If I take this one, another example, now I have sine. You know, this is the graph of sine that we have it here, if you remember. This is the graph of sine, 0, 1, 0, minus 1, 0. So you have in sine 0, 1, 0, minus 1, 0. Now the amplitude is absolute value of minus 3, which is a 3. Now the period is 2 pi over coefficient of x. Coefficient of x here is 1. So 2 pi, you divide 2 pi by 4. So the length of each quadrant is pi over 2. The phase shift from where I start the first rotation, you equate this to 0. You have x equal minus 2. So this is the phase shift. So I start by minus 2, as you can see. I add pi over 2 for each one. Minus 2 plus pi over 2. Another pi over 2 if you add it to this one. So it will be minus 2 plus pi over 2 plus pi over 2 is pi. If you add another pi over 2, pi plus pi over 2, it will be minus 2 plus 3 pi over 2. And the last one will be, if you add here another pi over 2, it will be minus 2 plus 2 pi. So the original one is minus 2, and the last one will be this one plus this one, minus 2 plus 2 pi. Now, I want to put these numbers. As I said, suppose this is all sine x, so I multiply each one here by minus 3. Minus 3 times the number that I have, plus 2. So if you put the first one to be 0, minus 3 times 0 plus 2 is 2, as you can see. Minus 3 times 1 is minus 3 plus 2 is minus 1. The third one, minus 3 times 0 plus 2 is 2. Minus 3 times minus 1 is a 3. 3 plus 2 is 5. The last one, minus 3 times 0 plus 2 is this one. So the first point is minus 2, 2, as you can see. I'm graphing the sign here. Minus 2 plus pi over 2. Approximately, it's minus 2 plus 1.5. It is minus 0.5. Around minus 0.5, it's minus 1. Here, minus 2 plus pi in 1, around 1 and 1 or 1 point, it's 2 here. Here, minus 2 plus 1.5. Okay, sorry, 9 over 2. 9 over 2, if you take pi to be 3, 9 over 2, 4.5. It's 2.5. Around 2.5, it's 5. Around 2.5, here it is 5, as you can see. This is the fourth point. The last one, minus 2, around minus 2 plus 6 is 4. So around 4, it is 2 in a 4 more because this is 6.28, don't forget, but I'm taking it approximately. So I graph the function that I have. Okay, now this is the cosine x. You know the cosine x, we start by 1 0 minus 1 0 1, the fourth quadrant. So 1 0 minus 1 0 1, since I have cosine. Amplitude is 0.5. Period is 2 pi over coefficient of x, which is pi. You divide it by 4. So pi over 4 is the length of each quadrant. You equate this to 0 to know from where I start. So x will be pi over 2. So the first one is pi over 2, and you add to it pi over 4. So pi over 2 plus pi over 4 is 3 pi over 4. So this is the second quadrant. If you add another pi over 4, it will be, because I'm adding the length of each quadrant, so 4 pi over 4, which is pi. If I add pi to pi over 4, it will be 5 pi over 4. If I add here pi over 4 to 5 pi over 4, it will be 5 pi over 4 plus pi over 4, so 6 pi over 4, which is 3 pi over 2. So let me check. The first one must be pi over 2, the phase shift, I have it. And the last one must be pi over 2 plus pi. Pi over 2 plus pi is a 3 pi over 2. So my work is correct. Now I need to multiply. Suppose this is the cosine x. I multiply by 0.5 and then I add 0 in without adding because I don't have a number here. So multiply each one by 0.5. So here 0.5. Here 0, it stays 0. 0 times 0.50. Here minus 0.5. Here 0, and the last one 0.5. So pi over 2 around 3 over 2, 1.5. So 1.5 is 0.5. Here 9 over 4 is 2.25 is 0. You can see it here. Here. The third one 3 is around the 3 point, and here it is minus 0.5. Here 5.5 pi over 4 around 4. 15 over 4. So here you can see it. It is around 0. The y is 0. And the last one, 9 over 2 is 4.5. It is what? 0.5. You graph the cosine x. So this is one quadrant. And you keep repeating from both sides the same strategy. Okay? The same way. And the period here, as you can see, is pi. From here till here is pi. From here till here is pi. This is another rotation. This is another rotation, etc. from all sides. So this is the graphing trigonometric function. This is the way. This is the easiest way I can find to graph sine and cosine. Thank you for listening.